Hello, everyone. I'm Dr. An. Python is the to-go language for machine learning and artificial intelligence. This module covers all the basics of Python programming that allows you to start immediately with performing machine learning and artificial intelligence tasks. Let's dive into the Python programming tutorial right away. Hi everyone, I'm Dr. An. Let's dive into the Python basics. As you can see, I opened a Google Colab file. We'll be working on this file, and you can download the file following the show note. Now let's first talk about the basics for Python, including printing and getting help. Here you can assign values to a variable. So here I assign a value of 3 to the variable x. And then you can print out the value for x, and you can see that x is printed at 3. You can assign multiple values to multiple variables in this format. So I assign value 3 to A and value 5 to B at the same time. So if you print out A and B, you will find the corresponding values here. You can also return the type of variable x by using the command type x. And as you can see here, x is an integer. You can show documentation for the print function using the function help. So you type help, and in the bracket, you supply the function name, print. And in this case, you'll be able to take a look of the detailed command for print. Now let's talk about strings. You can assign a string to a variable in Python fairly easily. You just type, for example, s1, which is the name of the string, equals hello, and make sure that you use either single quote or double quotes for the string so that Python will recognize as a string variable. You can also assign a multi-line string to a variable using 3 double quotes or 3 single quotes. And the 3 double quotes or single quotes are also helpful if you want to include in the string the double quotes or single quotes as characters. For example, here I have a multi-line string, and in the string we have some double quotes and single quotes here. If you print this multi-line string, you will see that the string reads, "She said that's a good idea." You can return the number of characters in the string using the len function. Then if you use len s2, s2 is the multi-line string we just assigned to variable s2, you will see that there are a total of 32 characters in the string. And actually, you can count the string one by one, including the empty space and punctuations. There should be exactly 32 characters in total. If you want to test whether the string starts with a substring, HEL, lowercase, you can use the start with function, and you provide the string that you want to search for in the bracket, serving as the argument for start with. And it's going to return either true or false depending upon whether the string is indeed included in the string s1. In this case, because s1 is assigned as hello, so it does contain the lowercase HEL. Therefore, it returns true. And here we test whether the string ends with the substring OW lowercase. And because S1 does not contain OW, it contains O but not W. So therefore, because the hello does not end with OW, it returns false. We can also find a substring in a string using the find option, the find function. S1.find and then provide the substring that you would like to look for. And then if HE, for example, the lowercase he is included in the string S1, is going to return the position, basically the index of the string where it starts. But if there's no such string, then it's going to return -1. For example, here, because the lowercase he is at the beginning of the string S1, hello, so therefore the first index for the lowercase h occurred at the very first character in hello, so therefore the corresponding position is 0. So 0 is returned. Whereas if you use capital H and then lowercase e, because the string and substring are case sensitive, so there's no uppercase H in the S1 hello, and so therefore it returned -1, denoting that this substring is not included in the string. You can return a string with the values inserted. There are two ways to insert values into a string. The first one is to provide the string first. And in the string, you use this curly bracket. And then you use the format function. And in the format function, you provide the numbers, the values in order. So basically, when you print out the results, 3 is, because it's at the first position, is going to replace the bracket here. And 1 is going to replace the bracket here. And 4 is going to replace the last bracket here. So therefore, the printed output is 3 plus 1 is 4. The second way to return a string with the values inserted, we can do this way. For example, we assign a equals 5, b equals 2, and c equals 7. And we use f at the start of the string, before the string. So f here stands for format. And then you provide the string in the double quotes. And in this way, you can directly insert the variable into those brackets. So if you print the results, you will see that those values, those variables values are evaluated in the string. So it prints out like 5 plus 2 is 7. You can return a new string with all occurrences of a character or a substring replaced by another character or another substring. For example, here we want to replace the lowercase e in the string S1 hello to a uppercase e. We can use the replace function. So S1.replace, and then the old substring or character you want to replace with, and then the new character or substring you want to replace the old substring with. And as you can see in the results, the lowercase e in the hello has been replaced by an uppercase e, but the other characters in the string are unchanged. We can split a string into a list of strings based on separating a character using the split command. For example, here I have a sentence as a string, I like drinking tea. I assign the string as S3, and then I can use the split function on S3, and in the bracket, I supply the argument as the empty space, denoting that I'm going to use the empty space to separate the string S3 into a list of strings. If you print the results, you see that the result is a list of 4 strings. I like drinking tea, and there's no space between because we use the empty space to separate the string into 4 strings and put them in a list. So actually, the split function uses white space or empty space as the default to separate the string. So therefore, you actually won't have to provide the empty space string. You just use the split function directly without providing an argument, and you would see the same result. There are other commonly used string operations. For example, you assign this as my string, and you can print my string times 2. So this asterisk denotes times or multiply in Python. And then what is this doing is just print the my string twice. So the output will be this. Therefore, a string times a integer value just means repeating the string for a number of times. And if you use my string plus another string, empty space hat, you see actually this is concatenation because the 2 strings are now as combined to a larger 1 string, this empty space hat. You can also test whether a character or substring is included in a string using the in function. So for example, I print O in my string. Remember, my string is this, and O is not a character in my string, so therefore the result is false. We can turn a string, the characters in the string to lowercase by using the lower command function, and we can also turn all the characters in the string to uppercase using the upper function. As you can see that this operation turns the lowercase this to all uppercase, and the lower is going to make the entire string, all the characters in the string, to lowercase. We can count the number of characters in a string. For example, here I count the number of the character t in my string. Because in the string this is only 1 t, so therefore it returned the value of 1. We can remove any leading, basically the beginning, or treating, basically at the end, space, empty space, no matter how many spaces are there, from a string pretty easily using the strip command. So here we have a leading empty space and also treating empty space in the string apple. And if we use the strip method, you will see that the leading and treating spaces are removed by the function. And now let's talk about numeric types and math operations in Python. So you can convert this string 5. I know this is a string because the value is within the single quotes, so it is treated as a string. But we can convert the string 5 to an integer 5 by just issuing the function int stand for integer. So integer string 5 is going to return the integer 5 as printed out here. You can also convert the string, for example, 2.5 to a float value 2.5. So using the float function. So float string 2.5, and then it's going to convert the string to the float number 2.5. To some of you who are not familiar with float, float number is just a number with decimal points in comparison to integer. And you can raise the value of 3 to the power of 2 by using double asterisk. So 3 double asterisk 2 is going to return 9. You can also do divisions using Python. So 55 \9 is going to do the division. So the output will be 6.11. And you can also get the quotient of this division using double \. So 55 \9 is going to give you the quotient with value 6. You can also get the remainder using the percentage sign. So 55 percentage sign 9 is going to give you the remainder, which is 1. And for beginners of Python, people are often confused by this plus equal sign. So let me explain what it is. So plus equal sign is just a simpler way of saying x equals x plus 1. So this would be the same as x equals x plus 1. Okay? So if you assign value 5 to x, and then x plus equal 1, the x is going to be equal to 6, right? Because the equations are going to be evaluated from right to left. So first, 5 plus 1 is evaluated, and then Python is going to assign the value of 6 to the left-hand side x. So therefore, x will be equal to 6. Analogously, you can also use minus equal. That will be just a shorthand of writing x equals x minus 1. For example, if you assign 5 to the value of x, and then x minus equal 1, x would be equal to 4. Analogously, you can also have x asterisk denoting multiplication and then equal to. And that will be the same as x equals x times 2. So therefore, the x will be equal to 10. And you can also do x backslash denoting division equal to 10, because x equals 5, so that x equals x divided by 2, then x would be equal to 2.5. And now let's talk about lists. We can assign a list containing some integers. So list is a very useful feature in Python, and list can contain nearly every object. You can have integers, you can have floats, you can have string, you can have any other objects in a list. So a list is completely flexible. It's a way to organize your data no matter what type of data you have. So here we create a list containing the integers. There are 4 integers, 100, 21, 88, and 3. You create a list by using this hard bracket on both sides, and then you want to separate the elements in the list using the comma. Then you can print out the list. As you can see, the list is created for you with the 4 elements. And many times you want to create an empty list as a placeholder, because later on you want to append values to this empty list. There are at least 2 ways commonly to create an empty list. One is to use the list function. So list bracket, you do not provide any argument, and then a empty list is created with no elements. The second way to create an empty list is simply use the hard bracket, but without any value inside. So both would give you an empty list. You can return the first and last value in the list, or any value in the list, actually using the index. So if you want to return the first value, you just provide L, and then in the hard bracket, you provide value 0. So the reason why you provide value 0 is because the index in Python always starts from 0. So for those of you who use R or Stata for a while, this could be a little bit confusing, because the R and Stata use position 1 to denote the very first element in the list, whereas in Python it uses the index start from 0. So therefore, in Python, the 100 is the first element. It has an index of 0. 21 has an index of 1. 88 has an index of 2. And 3 has an index of 3. So L0 is going to give you the first element, 100. And L3 is going to give you the last value, 3. And another way to return the last value is to count backwards. Instead of counting 0, 1, 2, 3, from left to right, you can count from right to left by using a negative number. So -1 denotes that you are going to count backward, and you get the first value by counting backward. So therefore, L minus 1 is going to give you the last value in the list, which is 3. You can return a slice of a list containing 1 or more numbers. So here I use L, and then 1, 2, 3. So this is going to, you probably think, if you have never used Python before, that is going to return you 3 values, because 1 is the second position, the second index in the list, corresponding to 21, because remember, the index starting from 0, and then 1, 2, 3. So it includes position the 88 at the position 3 and also include the last value in the list. So you would think that Python is going to return you 3 values, 21, 88, and 3. But if you issue a command, you are going to find out actually Python only returned 2 values, 21 and 88, but excluding 3. So this pertaining to another Pythonic operation because by default, the Python is going to exclude the very last position or index. So therefore, the index 3 corresponding to the last value in the list is not included, is excluded from the slice, so that you only get 2 instead of 3 values from this operation. We can provide more slice examples for this. For example, how about we get the positions or indexes 0 and 1. So if we do not provide any value here, it denotes that we are going to start from position 0. And then we are going to end with position 2. So in this case, we are going to get here the position 0 and position 1. So this will be 121 returned. And how about if we want to get position 1 all the way to the end of the list? By the same token, if we do not provide any position, here it denotes that we are going to slice all the way to the end of the list. So therefore, L12 is going to return from position 1, which gives you 21, and then 88, and all the way to the end of the list, which is 3. If you want to return all positions from index 0 all the way to last index, you do not provide any values to the left and to the right. And in this case, the entire list of all the elements are going to be returned. So here we show you how we can subset a list of a list. So here we created a list, and this list has 3 elements. The first element is a list. The second element is another list. The third element is also a list. So this is called a list of lists. And how about, say, we want to return the value 4. First, we need to identify this list from L1. And this list is at position 1 because remember the positions in list always start from 0. So therefore, L10 is going to return this first list. L11 is going to return the second list. And L13 is going to return, L12 is going to return the last list here. So therefore, if you want to return the list 2, 3, 4, you need to have L11. But L11 only going to give you the list 2, 3, 4, but what you really want is 4, the last element in the list. So remember, there are 2 ways to return the last element. One is to come from left to right, so you have position 0, position 1, position 2. So therefore, L12 is going to give you the value 4. Another way is to count backwards using -1, because 4 is the last element in the list. So therefore, if you issue the command L11 -1, it's going to give you 4 as well. And how about if you want to return, say, the first 2 elements, 1 and 2, by subsetting the list? First, of course, you need to identify the first list in L1, that is just L1 position 0. And then on 1, 2, it means that you are going to include position 0, position 1. And remember, because Python is last position exclusive, so therefore you need to go to position 2 as well. So in this case, if you do not provide any position here, it means that you are going to start from position 0 all the way to position 2. Then this is going to give you the subset of 1, 2. And now let's take a look of how you append a list or duplicate elements in the list. So here I create a list of containing 3 strings, string this, string this, and string nice. So if I use the this operation, my list plus L, remember L we defined before as a list containing 4 integers. And then my list plus L is to append L to the my list. So it's going to concatenate these 2 lists together to form one large list containing all the elements from my list and L. So in this case, a list is extended to having 7 elements. This is nice, 121, 88, and 3. So this is a unique feature in Python because though the data types, including the list, won't have to be the same. So a list can contain strings, integers, and other objects in the same list. How about if I want to duplicate elements in the list? Well, a convenient function is my list and then times 2. This is going to repeat all the elements in the my list 2 times. So the output would be a larger list with this is nice, those 3 elements repeating themselves once. So there will be this is nice and then repeat this is nice in this larger list. You can return the number of elements in L using the len command. Remember, previously we used the len command to return the number of characters in the string, and len can also be used to return the number of elements in the list. So len L1, you're going to return 3 because there are 3 elements. This is nice. Sorry, this should be referred to the L1 denotes here. So the L1 have 3 elements, which are 3 lists. So therefore, the len L1 is going to return number 3. And you can return the sum of all elements in the list using the sum list. Of course, it is only eligible if the L contains numerical values. You can also return the minimum value in the list and the maximum value in the list, as shown here. You can append a value to the end of a list using the append function. So L previously contains 4 numbers, 121, 88, and 3. If you append 16, then if you print out L, 16 is added to the last position in the list. So append is a highly useful function in machine learning and data analytics in general. And remember that append always append the value to the last position in the list. You can get the index of an item from a list. So for example, the my list contains 3 elements. This is nice. And you use the index function, and in the index function, you provide the item that you want to know is corresponding index. Then this is going to return you the index associated with this, because this is in the position 0, so therefore the index is 0 returned. You can count an item in the list using the count function. So mylist.count and then provide the element that you want to count because is only appeared once in this list. So therefore, it return a value of 1. You can remove an item from a list. There are multiple ways that you can remove an item that we introduce 3 ways here. They all differ a little bit. So the first option is to remove by value and only the first instance. For example, here we create a list of 1, 2, 2, 5, 19, and 20. If I say L remove 2, is going to remove the first 2 from the list, whereas the second 2 is still intact. As shown here in the results, the first 2 is removed, and then the output list would be 1, 2, 5, 19, 20. The second option is to remove by position. So using the del stand for delete command. So if we say del L1, because we are working with this list, the L1 is the second position corresponding to a value of 2. So therefore, del L1 is going to remove this 2 from the list. So therefore, the resulting list would be 1, 5, 19, and 20. And the third option is to remove by position and also return the value removed using the pop command. So L.pop -1, because this is counting the list backwards, so the very last element in the list is 20, so therefore 20 is going to be removed from the list. And so that the L.pop -1 is going to return the value that is removed, which is 20. And if you check the list later, the list is going to be just 1, 5, 19 because 20 has been removed from the list. And if you ask me, no, how about if I want to remove both 2's from the list in one go? Right? So in this case, you can use list comprehension. Just to briefly mention list comprehension here because later on in a minute, we are going to introduce you list comprehension in detail. So here we still have the list of 1, 2, 2, 5, 19, 20. To use list comprehension to remove all instances, you just need to provide the list comprehension in this fashion. So I for I in L, so L is the list, and I for I in L, meaning that I'm going to return every single element in this list, but then I provide an if condition, if I is not equals to 2. So this means not equal to. So therefore, it means that I'm going to return every single element in the list as long as that element is not equals to 2. So therefore, if you take a look at the results, the 2 is not shown in the resulting list because the value 2 does not satisfy this if condition. So don't worry if the list comprehension operation doesn't make sense for you. We'll talk about it, revisit this question a little later. Now let's take a look at how we can reverse a list. So here we have a list in the order of 1, 2, 5, 19, 20. If I issue the function reverse, then if you take a look at the list, the last value is going to occur first. The second last value is to return second, and so on and so forth. So basically, it completely reverses the order of all the elements in the list. You can insert an item in the list by position. So for example, here you say I'll insert, and then you provide the position where you want the item to be inserted, and then you provide the item that you want to insert into the list. And then as you can see that -10 is inserted to the position 1 in the list. So previously this was 2019, now it's 20 minus 10 because -10 now take the place at position 1, and all subsequent values are moved one position, shifting one position to the right. So therefore 19 is shifted to position 2, and 5 is shifted to position 3, and so on and so forth. You can sort items in the list in either the ascending order or descending order, and there are two ways to sort a list. The first option is to use the sorted command. The sorted command make actually no change to the original list. So therefore, if you want the sorted list saved, you have to assign it to a new list. So here we use sorted L, and we assign the sorted list by the ascending order to a new list called L2. So if you print L2, you will see that in L2, the smallest value start first, and the largest value stay at the last. So it has been sorted in the ascending order. And the second option is to sort in place. Basically, you make change to the original list using the sort function. So L.sort is going to make sort the list by ascending order and save the result directly on the list. So it changes the order of the list L directly. So if you print L, you find out that the L has been sorted based on the ascending order. To sort items in descending order, you just need to use the sorted function, and then you provide the argument reverse equal true. So in this case, it's going to sort by the descending order of a list so that the largest number appear first and the smallest number appear last. You can convert a list of strings into a single string using the join function. So for example, I have a list containing 4 strings A, B, C, and D, and I want to concatenate it to a single string A, B, C, D, but with empty space in between. I can provide the empty space and then dot join, and in the bracket, in the argument, I provide the list I want to join. So the result would be a single list of a single string of A, B, C, D. And as you can see, they are separated by the empty space because we asked join to do so. So tuple is very similar to a list. So it is actually behave most likely like a list, but tuple is immutable. So basically, you cannot change the values in the tuple, but you can change values for a list. So one common way to use tuple is in combination with the zip function as illustrated here. So here we first created a tuple. Tuple is created by using this curly bracket, and you supply the elements in the tuple, also separated by the comma. So here I created a tuple we call A, containing 3 people's names, John, Charles, and Mike. And we create a second tuple B containing 3 elements, 53, 29, 44, denoting the ages in years for those 3 individuals. And then we use the zip function, zip A and B, So the zip function is going to pair the values from A and B. So if you create a list of this zip object X, you will see that in the list there are 3 tuples, and each tuple is a pair of a name and a corresponding age. So basically, zip function is going to pair join the first element in A with 53, the first element in B, and also pair the second element in A with Charles with the second element in B, which is 29, and also pair the third element in A, which is Mike, with the corresponding age, the third element in tuple B. And now let's talk about list comprehension. So list comprehension is a very useful function in Python, but it could be confusing to beginners because if you're familiar with SAS or R or Stata, there's no similar function. So it's a very Pythonic way of organizing your data. So let's illustrate how and why list comprehension can greatly simplify your code. For example, here I want to construct a new list with selected items from an arranged list. Say I created a list called fruits, and the list containing the following fruit names: apple, banana, cherry, kiwi, and mango. And I only want to include a fruit name if that fruit name contains character A. So basically, I want to I want to create a utility function so that we can only include apple, banana, and mango in the revised list because all 3 contains character A, whereas cherry and kiwi do not contain A, so they should not be included in the revised list. So to do that, well, actually you've been provided all the elements, all the tools to handle that operation. You can first create an empty list called new list, and then you can use a for loop. No worry too much about for loop and if condition because we are going to introduce them a little later. So basically, the for loop is that you are going to loop through each element in the fruit. Basically, go through apple first, and then banana, and then cherry, and kiwi, and then mango. And if X, which is an element in fruit, contain the character A, so the if A in X, meaning that it's going to do a testing. If A is in the element, for example, if A is in the first element apple, it's going to return true, otherwise it's going to return false. So, for example, if X equals cherry, and then if A in X is going to return false. And you are only going to append the element X to the new list if this condition is true. So the resulting new list, as you can see, containing only 3 fruit names: apple, banana, and mango, because all 3 have the character A, whereas cherry and kiwi are excluded because they do not contain A. Well, of course, no, you can do this utility function fairly straightforward. But it takes 4 lines of code, and you include a for loop and also an if statement, right? Which is a little bit complicated. So is there a simple way to do that? Actually, you can use list comprehension to do the above task by just using a single line of code. So the grammar for list comprehension is the following. you create using hard bracket a list, and in the list you follow this grammatical rule. So expression for items in iterable if condition is true. So basically, expression is any function that you could include that work on the item. And then for items iterable is just means any object that can be iterated in Python. For example, a list can be iterated because you can use a for loop. And a table is also iterable. And later on, you're going to learn dictionary and also iterable. So as long as it is iterable, you can use the for loop. So for item iterable means that I'm going to go through each element, each items in this iterable, for example, the list, and I'm going to do a function on the item. So here the function is actually identity function, it's just the item itself. And then you are only going to operate this if you have some condition holding true. So if we use this grammar for this comprehension to select the fruit names that has the character A, it's just one line of code here. So for I in fruits, so I is the identity function, identity expression. So we are only going to select the items in fruits if A is in I, if the character A is in that fruit name. So if you print this new list, the list is identical as the previous list when we use a for loop and a if statement inside. So therefore, as you can see, the list comprehension greatly reduces the code complexity, and therefore it is very popular among people who are using Python on a daily basis. And now let's move on to talk about dictionary, which is another very useful feature in Python. So if you think about dictionary, the main function for a physical or digital dictionary is for you to be able to check out something. So for example, if you know some keys, say an abbreviation of a word or the spelling of a word, and then you can check the full definition of the word from the dictionary. And the dictionary in Python works really similar as the original dictionary in our daily lives. We can create, for example, a dictionary with the following keys, CA, GB, and IN. And they are just abbreviations for Canada, Great Britain, and India. And creating the dictionary is super simple. In the curly bracket, you provide the key value pair. So the keys are provided first, and then the value corresponding to the key is provided second. So in this case, we create a dictionary with 3 keys, CA, GB, and IN, and their corresponding values are Canada, Great Britain, and India, respectively. So if you print the dictionary, you will see that the dictionary printed as we constructed. So the dictionary is only useful if we want to return some values from the dictionary. Basically, we use the key to check the value. So here we return the value from dictionary D that has the key GB. So D and then hard bracket GB, which is one of the 3 keys in dictionary D, and the returning value is Great Britain. And sometimes if a key is not in you provided to the dictionary is not included in the dictionary, it's going to issue you an error message. One way to guard against an error message that stops your code execution is to use the get command or function. So if you use dictionary and .get, then first you provide the key. So if the key does exist in the dictionary, it's going to, of course, return the value. But if the key does not exist in the dictionary, you are going to specify an alternative message that is going to be returned. So, for example, here, I say dget AU, and the program is first going to check whether AU is a validate key in dictionary. If it is, it's going to return the corresponding value, but if not, it's going to return this message. The dictionary does not have this term. So because AU, as you can see, is not a key in the dictionary, so therefore the dictionary does not have this term, the string is going to be printed, to be returned. Whereas in the second example, because CA does exist as a key in the dictionary D, so therefore the corresponding value, Canada, is returned. You can return a list of the keys from a dictionary just using keys function. So d.keys is going to return you all the keys in the dictionary. And similarly, you can return the list of all the values from the dictionary using .values. And you can also return a list of key value tuple pairs from the dictionary using the items. So as you can see that it returns all three key value pairs as tuples from the dictionary. You can also create a loop to go through the key value pairs in D by using the for loop. So for key value in D dot items, and you want to print the key, and then all three keys are provided. So in this for loop, make sure that you provide both key and value as a tuple, because when it extracts the returned values from the dictionary, is going to return in the format of key value pair. So that each key is going to be assigned the corresponding value for the key, and each value is going to be assigned to their specific value. So therefore, make sure that you provide a tuple with key value so that they can be assigned the corresponding values from the dictionary items. And now let's talk about modules and functions. To import a module, so module is a library that is not built in Python. So Python, although has a lot of built-in functions and modules, but to accomplish a specific task, for a lot of time we need to import additional modules to Python. So there are various ways that you can import modules. The most common way is just to use the import and then follow the module name. So import random is going to import the module named random to the Python. So you can import the module directly without installing the module in the first place, is because the Google Colab have already pre-installed a large number of commonly used modules for you. But if the module is not pre-installed, no, you have to install the module first. So in later sessions, we are going to talk about how you can install a new module into the Colab. And the second, for sometimes you don't want to import the entire module, but you only want to import either a submodule or some functions or method from the module. And a way to do that is to use the from import function. So from math, meaning that I'm going to import something, a submodule or function from the module named math. And then import sqrt is going to import the specific function called sqrt from the math module. So from math import sqrt means that you are going to import only the function sqrt from the math without importing the entire module. And now let's talk about how you can define a function. Defining a function in Python is really simple. You need to use the def function denoting define, and then you provide the name of the function. You can be creative what name you can provide, but best practice is you want to give a function name that makes sense and corresponding to the utility of that function. So here I will just give it a relatively generic name called calculate. And then in the bracket, you need to provide the argument or arguments for the function. So here we have 3 arguments. The first argument is called value 1. The second argument is value 2. And the third argument is exponent equal 1. As you notice that, so the only argument that has an equal sign is exponent. So exponent equal 1 means that you assign 1 as the default value for this argument, so that if you do not provide, when you execute the function, initiate the function, if you do not provide a value for exponent, by default, exponent is going to be assigned a value of 1. On the other hand, you do not assign any default value for value 1 and value 2, so therefore, when you initiate a function, you have to provide these corresponding values before the function can be initiated. And then you want to indent your subsequent functions, no matter what it is. So indentation is very important in Python because there's no hard or soft brackets to allow Python to know that the following equation are part of the function. So therefore, the Python can only recognize that if you provide the indentation. So make sure that you provide indentation correctly so that Python will know that the corresponding line of code belongs to the calculate function. So the function is very simple. The function is basically look like this. You have value 1 plus value 2 and then raised to the power of the exponent. And then you want to return the results of the function. So a lot of people who first learn about Python are kind of confused between return and print. Well, print literally is that you print out some value to the screen, which is fundamentally different than return, because return is that you return a value so that later on you can, say, assign the value to some other variables, whereas print cannot assign the printed value to any variable. So therefore, a good practice for the function is most likely you create a function in the first place because you want to return some output. So therefore, it is a good practice to use the return function in case you want to return some result. And then let's evaluate the function, initiate the function as calculate. Remember, you need to provide the values for value 1 and value 2. So here I provide 2 as the value 1 and 1 for value 2. And as you notice, I do not provide a value for exponent, so therefore the function is going to use its default value exponent equals 1 when evaluating the function. So another way to be more explicit is to write value equal to value 1 equal to and value 2 equal 1. So if you write this way, you have the flexibility of exchanging its order. For example, putting value 2 first and then comma value 1. The function still is going to be evaluated correctly because you have assigned the values to the corresponding argument clearly. But if you do not provide those keywords as argument, then you need to make sure that the values corresponding to the argument. So 2 will be recognized as the value for value 1, and 1 is going to be assigned to the argument value 2 based on its order. And if you execute this function, you are going to get, because value 1 is 2, value 2 is 1, and we use the default exponent 1, so therefore it's just 2 plus 1 raised to the power 1, and you get 3. And in the second line of code, I override the default value exponent so that exponent now equals 2. So therefore, if you evaluate the function again, that's 2 plus 1 raised to the power of 2, so that you get value 9. And here are some optional points that acknowledge that you can take a look, but they are not essential in the machine learning tasks that we are going to do later on. So feel free to check them out. We'll just briefly mention them here. So we can use the single star ARGS stand for arguments, or double star KW stand for keyword arguments. When we have an arbitrary number of arguments we want to pass to a function. For example, you can define a function mySum, and then you use asterisk and then arguments. And then in these arguments, you can provide an arbitrary number of arguments, and they are going to be used by the function. So for example, here you first assign 0 to the variable result, and then you provide a for loop. For x in arguments is going to loop through each of the values in the arguments that you are going to provide. And then you are going to calculate the results. Results we go to results plus x. So basically it's going to do the cumulative sum for all the elements in arguments for you, and then you return the cumulative sum. So in this case, well, you can provide many arguments as you like. So here I provided 3 arguments, 1, 2, and 3. So if you run this function, remember first result is 0. So the first time you run the for loop, the x is going to be assigned as the first value in the argument, which is 1. So 0 equals 0 plus 1, you get result 1. And the next time result 1 is going to be add to 2, because the second time when you evaluate this for loop, x is going to be equal to 2. So 1 plus 2 is going to be equal to 3. And the third time it is evaluated, x is going to be assigned a value of 3. So 3 plus 3, you get the cumulative sum of 6. And you can also have a combination of arguments. So you can have a required argument that you have to fulfill, and then you can also have an arbitrary number of extra arguments that you can have, but you won't have to have. So here we illustrate this activity. So you have asterisk arguments here as the second argument, so that here the first argument, argument 1, is required. So you have to provide this argument as a minimum to define the function, to initiate the function. But later on, you can also provide other additional arguments if you want to. So we define the main function. We first want to print the first argument, and then we are going to loop through the additional optional arguments. If we do that, we are going to see that, well, the first argument, argument 1, is assigned a value of hello, and then we can provide arbitrary number of arguments to follow the first argument, and we print them out as well. So this is just to showcase that you can combine the required arguments with a list of arbitrary arguments using the asterisk arguments. And sometimes you may also see that we use the special syntax double asterisk, and then KW stand for keyword arguments. So this special syntax is used to pass a keyworded argument list. So you could imagine that this double asterisk keyword arguments as being a dictionary that maps each keyword to the corresponding value that we pass alongside it. So here, for example, you define a concatenate function, and in the function you provide the arguments as double asterisk and keyword arguments. And then first you create an empty string and assign that to variable result. And then you can iterate over the keyword argument, because the keyword argument is treated as a dictionary. So dictionary has keys and values. And then in this case, I'm going to iterate over all the values, each values in the keyword arguments, and I'm going to concatenate the results, because each argument I'm going to provide is a string, so that I can concatenate results together. So for example, here, I provided arguments as A equals real, B equals Python, C equals is, D equals great, and E equals a punctuation. And then if I use concatenate, initiate the concatenated function, it's going to treat all those arguments as a dictionary. And in the dictionary, the first key is A, corresponding value is real. The second key is B, corresponding value is Python, and so on and so forth. And then, of course, if we run this for loop, it's going to iterate over all the values one by one. Real, Python, is, great, and then concatenate together. So therefore, the result would be a concatenated string variable, real Python is great. We can also use the double asterisk keyword arguments in a function by directly calling and using its values in the computation. For example, here we define a function called multiply, and the returned result is just the values corresponding to the key A and the values corresponding to the key B, their multiplication. So if you initiate the function, you assign argument A equals 4, argument B equals 5, and argument C equals 3. And then, so basically, the return is going to calculate the corresponding value for key A, which is 4, times the corresponding value for key B, which is 5, so that you get 20. So note here that although you provided argument c equals 3, c equals 3 is not evaluated because it is not shown in the function. There is an even simpler way to create a function. It's called a one-line function using lambda. So lambda acts and then provide the function itself and use a bracket to contain them together. So this itself form a function, and the function, you won't even give a name of the function because this is just a one-line simple function, a lambda function. And so basically, when the input would be x, and then the function is going to return x raised to the power of 2. And then you can directly provide the value for evaluating the function, and the value is 6. So therefore, this lambda function is going to return 6 raised to the power of 2, so you get 36. And now let's talk about Boolean comparisons. Boolean comparisons is very useful in Python. So here we assign x equals 18 and name equals Alfred, which is the string variable, and L is a list containing 5 integers, and then also a dictionary with 3 key value pairs, A1, B2, and C3. And then we can do a variety of Boolean comparisons. Boolean comparisons is going to test the equality or inequality of an operation, and it's going to return true if these conditions hold. Otherwise, it's going to return false. So here, first I'm testing whether x is equals to 5. Note that here we use x double equals to 5. So double equal in computer language means testing the equality, whereas single equal sign, as you have learned, means assignment. So here I'm testing whether x is equal to 5. Because x is equal to 18, so therefore it's going to return false, as shown here. And in the second Boolean comparison, I test whether x is not equal to 5. And then because x is equal to 18, not equal to 5, so therefore this evaluation gives you true. And you can also do this x greater than 5, testing x less than 5, or greater than or equal to, less than or equal to 5 pretty easily, straightforwardly. And you can also combine 2 or more Boolean comparisons using the or and. So here, for example, I'm testing whether x equals to 5 or name equals to Alfred. So as long as one of these conditions hold, a true is going to be returned. Well, as we can see that x equals to 5 is false, but name equals Alfred is true, so therefore it's going to return true because we use the or operation. On the other hand, if we use the AND operation to combine these two Boolean comparisons, then if either of these two conditions is not hold, it is going to return a false. So, for example, here, because x is not equal to 5, although name equals Alfred is true, because we use the AND operation, it's still going to return false. And finally, if we want to test whether an element is existent in a list or whether a key is existent in a dictionary, we can use the in Boolean comparison. So we test 5 in L because 5 does exist in the list of L, so therefore it's going to return true, whereas A, we test whether A is in dictionary, is going to check whether A is a key in the dictionary because A does exist as a key in the dictionary, so therefore it's going to return true. Now let's talk about if statement and loops. So if statement will give you a lot of flexibility in Python. The complete grammar is if, else if denoted by ELIF or elif, and then else. Okay. So in reality, a lot of time you won't have to have else if. You can just use if else. And sometimes you don't even need to have else. You can, if it is simple enough, you can just use the if command. So the usefulness of the if statement is that it's going to evaluate the conditions one by one. For example, here we assign x a value of 3. It's going to first evaluate whether x is greater than 5. If this condition is true, it's going to print out x is greater than 5. If this condition is false, and then it's going to evaluate the second condition, whether x is less than 0. If this condition is true, it's going to print out the corresponding result that x is negative. Elsewhere, it's going to, if that condition is again false, we are going to evaluate the third condition, which consists of any cases when x is less than or equal to 5 but greater than or equal to 0. And it's going to print out x is between 0 and 5. Okay? So in this case, because x equals 3, when we evaluate the first condition, this if condition is false, so that nothing is printed here. And then the second condition, x less than 0, is also false. So therefore, the corresponding print option is not executed. And finally, we test every other condition, and because the x equals 3 is less than or equal to 5 but greater than or equal to 0, so therefore only the third print function is going to be executed, so that the printed outcome if 3 is between 0 and 5. We can use the for loop, which for loop is also widely used in Python and machine learning, to iterate over each value in the list or any iterable. And let's demonstrate that. So here we first use the range 10. So range 10 is basically it's going to start from 0. So it's going to give the value of 0, 1, 2, 3, and all the way. Remember, Python is last position exclusive, so therefore it's going to give all the values from 0 to 9 instead of to 10. So so if you create a list of the range object, you will see that you're going to get a list containing 10 numbers from 0 to 9. So if we want to iterate over the range object 10 and print out each value, as you can see that it's going to print out the values from 0 to 9. So in this case, range is an iterable, so that you can construct a for loop on that iterable. And the list is also iterable, so you can iterate each single element one by one from left to right using a for loop. So here, for items in list 1, 5, minus 2, minus 7, 10, and if you print the item, you are going to see that all the items are going to be printed one by one following the order in the list. And the while loop sometimes is also helpful, but less used in comparison to the for loop. So I listed here as optional. The while loop is very similar to the for loop, but you need to provide a condition, so that is when the condition is true, it's going to iterate and iterate the function until this condition is false. So that it illustrates how you can use a while loop. So first you assign value 2 to the variable x, and then you write while x less than 10, and then every time in the while loop you add 1 to x, so x equals x plus 1. So when you run the function, every time the function run is going to test whether x is less than 10. If the condition is true, it's going to run this function until x is greater than or equal to 10 when the program stops. So here, as you can see, first we are going to start with x equals 2 because 2 is less than 10, so this function is going to evaluate once, and that value x is going to be updated to 3. And then, of course, 3 is also less than 10, and then the function is going to iterate the second time, so 3 plus 1, you get 4. And 4 is still less than 10, so it's going to evaluate the third time until that when x equals to 9, and 9 is less than 10, so that the function is going to evaluate the last time when x is updated to 10. And then because x 10 is not less than 10, so in that case, the while function is going to take a break. So therefore, if we print the value of x, x equals to 10. And sometimes we can also use the enumerate function, which I would say is an enhanced for loop because it's going to return you both the value of the list as well as the corresponding index. This can be very handy when we have a need, not only for the value but also the corresponding index in the list. So here we created a list containing 5 values, 44, 55, 66, 77, 88. And I use enumerate list, and then I construct a for loop because the enumerate function of a list is going to give you the index as well as value. So therefore, you need 2 variables in order to contain the output from the enumerate. If you print the index value, you will see that the first time the loop runs, you get index 0 and corresponding value 44, which is the value at position 0 in the list. And the second time the index is going to be 1, the corresponding value in the list is 55, and so on and so forth. So that really concludes all you need to know about Python to help you get started with machine and deep learning. Thank you for your attention. I'll see you next time.